Okay, advanced maths, we're now going to do 7.6, which is all about parallel lines. Ooh, double L, no double R. Parallel lines and perpendicular lines. Okay? Now, with parallel lines and perpendicular lines, there's a few interesting things about them that's going to help you. So here's my Cartesian plane. X, Y, origin. I'm going to draw a line in my Cartesian plane. Okay, now we don't know much about this line yet, but I can tell you that this line here is parallel. Now, using our knowledge of parallel lines and alternate angles in parallel lines and corresponding angles in parallel lines, we know that this angle here is corresponding to this angle there. So those two are corresponding. Which means that tan, that angle, say it's A, is going to be the same for both of them. And tan A is going to be the gradient, or the rise over the run, which is the gradient. So parallel lines, unsurprisingly, parallel lines have got the same gradient. Parallel lines have the same gradient. Now, so if you are told that a line is parallel to another line, you could automatically know that whatever the gradient is, it's the same on the other one. So if you know the gradient on one line, you know the gradient on the other line. Okay, so if they tell you this line has got the point 2, 1, and this line has a gradient 3, you'd be able to use the point gradient formula to find out the equation of that line there. You wouldn't know this line yet until you get another point. Okay, so that is how we do parallel lines. Perpendicular lines are a little bit more difficult because perpendicular lines, their gradient is not the same, but it's actually the negative reciprocal. Okay? Reciprocal. The negative reciprocal is the gradients, okay? Let's write that in. Gradients have negative reciprocals, okay, in perpendicular lines. So if you know, let's draw a little graph here. Here's our Cartesian plane, X, Y, origin. We're going to draw a line in our Cartesian plane. There it is, okay? Now we know that this line has a gradient of 2, okay? Now some other line going by that is perpendicular, okay, perpendicular, it's going to have a gradient which is the negative reciprocal, okay? So the negative reciprocal means we have a look at our equation, at our gradient, at our number. Okay, so m equals 2, which is the same as 2 over 1. Remember, there is always a secret invisible over 1 on every single number in the world. Okay, and now what we're going to do is flip this number and also flip the sign in front. Okay, so flip that sign, flip that number. So if we flip, we're going to get equals negative, flip the sign, 1 over 2. So that is the gradient of that line there, negative 1 over 2. Now there is a way for me to prove this to you as to why it's true, but it's just easy enough to remember, and I won't fill up your brain too much with unnecessary proof. But remember that the perpendicular lines have negative reciprocal gradients. Okay, now the other important thing to know is that if you have a negative reciprocal, say you have A on B, the negative reciprocal is going to be minus B on A, okay? These two are negative reciprocals. Just like 2 on 1, the negative reciprocal was minus a half. The negative reciprocal of A on B is minus B on A. Now what if we multiplied these together just for fun? We did A over B multiplied by minus B on A. Well, what we'd notice is that the A's cancel out, okay? And the B's cancel out, and we're left with simply negative 1. So that applies to every single negative reciprocal in the world. Any line that you have which is perpendicular, if you multiply the gradients together, m1 times m2, you're going to get -1. So m1 times m2, if that equals -1, then we've got perpendicular. Oh, like that, but that's just a big U. And if you have m1 equals m2, then you've got parallel. Yeah, I spelt it right for the first time. Okay, so that's 7.6. That's what you need to know about parallel and perpendicular lines. Go forth, people. Go forth and mathematize.